In the second part of genetics, I wanted to show you pedigrees and karyotypes. On the board, I have the pedigree that's found in your packet. All your packet says is that in humans, free earlobes, big E, are dominant to attached earlobes, little e. Our goal in this pedigree is to figure out what the shaded represents. Does that mean it's got free earlobes or attached earlobes? So is it dominant or is it recessive? Here's how we figure it out. First and foremost, if you look, this should be shaded in. But if you look here, these two parents do not have the shaded trait. However, they have a child that does. That automatically makes them carriers, and I can honestly, and I know that these are big E, little e. This one has to be little e, little e. If it was any other way, they wouldn't be able to have the shaded trait, so they have to be carriers in order for this child to have it. That is my first dead giveaway. Also, if you look, here's a parent who has it, and nobody does. So that's also another giveaway for me. So now that I've figured out that the shaded one is little e, I can go and mark all the individuals that are shaded as little e, little e. And that's going to help me identify everybody else in this pedigree. So, here's the thing. Up here, we know for a fact that mom has to have a big E, because obviously these kids have a big E if they do not have it. However, it's very hard to determine if mom is big E, or big E, little e. Therefore, she's just going to be big E dash. As we come down here to this side of the pedigree, we see that this one is little e, that one's little e. They had to get two little e's in order to have it. So one comes from mom, and one's got to come from dad. So we can assume that he is big E, little e. Now that we've assumed that he is big E, little e, we can actually go back and say, okay, he got a little e from mom. This must mean mom is big E, little e as well. Because this person does not have the trait, this person is also big E, little e. Looking here, they had to get, well, actually we don't know what they are. They can be big E dash. Since they don't have kids, there's no way to really determine what's going on here. I think these are the only two we cannot figure out. Looking over here, we know that it had to have gotten a big E from dad and a little e from mom. That's all mom has to give. So this person has to be big E, little e as well. Dad, since he had kids that were little e, one came from mom, one's got to come from him. That's a pedigree. I'm looking at number 122, all these different karyotypes. In the first karyotype, if you look down the bottom right corner, it will show you the sex chromosomes. Either your XX, meaning you're female, your XY, meaning you're a male. This one happens to be XY, therefore it is a male. If you look, you don't see any duplicates, you don't see any monosomy or trisomy, therefore it's going to be a normal male. Looking at the second karyotype, you'll see that it has two X's, so XX meaning it's a female. As you look across, you'll see there's 3 chromosomes at the 21st location. Therefore, that means they have trisomy 21, which is also known as Down syndrome. The next one, again, is a female. There's 2 X's, nothing on the Y. And I don't see any monosomy or trisomy. I don't see 1 chromosome, 3 chromosomes, none of that stuff. So this is going to be a normal female. And the last one, if you look at the bottom, you see that this male is XXY. He's a male because he has a Y. That absolutely makes you a male. Unfortunately for this male, he has Klinefelters. Klinefelters will give him a lot of feminine characteristics. But XXY is Klinefelters. Monosomy and trisomy are caused by non-disjunction. The chromosomes don't separate properly. There should be 1 in each box, and instead there's an extra 1 in the box or something of that nature, just for an example. And that is ending genetics.